Hey, you know what's cool? Science. You know what's even cooler? Believe it or not, flocculants. I think they're cool, and I think it's because they kind of seem magical to me. So which is it? Is it science or magic? I'll let you decide. Hey, and big shout out to Kyla Wood with Applied Polymer Systems for coming on the pod and breaking down all things flocculant with us today. Hey, everybody. Welcome back to this episode of the Stormwater World podcast. We're going to talk flocculant today, and we've got the perfect person to lead us down the flocculant path. Let me introduce Dr. Kyla Wood. She is the technical director at Applied Polymer Systems, where she utilizes her expertise in aquatic toxicology and polymer flocculants to inform and train erosion and stormwater professionals, applicators, engineers, planners, and government organizations on safe and effective flocculant use. She holds a PhD from Clemson University and a master's degree from Northern Michigan University. Kyla, thank you so much for coming on the podcast today and being with us.
Yeah, thanks for having me.
So let's start off. Tell us a little bit about yourself and what you do, and then we'll kind of dive into the awesome world of flocculant.
Sure. Yeah. So again, I'm with Applied Polymer Systems, and I really I kind of grew up in this space, and it's kind of Applied Polymer Systems has really kind of driven the course of my career and my path. In that we're a family owned and operated company, and so the technology, the technology, the flock logs, the silt stop for water treatment, they actually came out of my father Steve was working for mining companies in Southeast Alaska and was using that technology to treat metals and turbidity in mining effluent. What he saw down in the southeastern United States is that they had a lot of clay soils and they had a lot of BMPs that weren't able to effectively improve the water quality with those physical BMPs. So he packed us all up, and the technology went down to the southeastern United States. And so I think I probably hit my first IECA at 12 or 13.
Wow. Okay. That's awesome. So
Yep.
you had no choice. You were locked in from,
Yeah,
oh my gosh, that's
definitely.
amazing.
Yep, high school work study was doing flocculant and soil samples. Um, yeah, and then
You were
eventually,
destined to write a dissertation. There was no
exactly,
way around it. That's
yeah.
awesome.
So I navigated away from APS, and did my master's and my PhD. But while I was doing that, I was still working on using chemicals in a safe and effective way to manage water quality. So I was looking at treating toxic algae with different types of algicides and things like that. So it put me in a really good position to work with chemical treatments and water quality. And now I'm back at APS, and my father since passed away in 2016, but me and my sisters have been picked up the torch, and we're still moving forward with
Oh my God, he's got to
APS
be
and
so
flock logs
proud.
and stuff.
That's
I think,
awesome.
yeah. Mm-hmm.
Kudos
So,
to you all for carrying it on. I mean, that's amazing. What by chance? What did you write your dissertation on? I feel like anybody that has their doctorate, we need to talk about it for a minute. Because congratulations to you. Because it's just people see that. I don't think everybody realizes the amount of work that is. What did you write your dissertation on?
thanks. Yeah, so I spent a couple years in some farm ponds at Clemson University, and I was researching how to use
Wow.
um, different types of algicides to treat toxin producing blue-green algae and see how it affected how the toxins were released from the algae and how they hung around in the environment. So basically, um, I did research on using algicides to manage toxin producing algae.
Wow, that's so interesting. But I could talk. We could talk about that some more. But we've got goals today. We've got goals,
Sure.
and so the first thing is to really let's break it down. I think the word flocculant is thrown around a little bit in the stormwater industry, and I think it is a very important. Um, I think it's important just in general. All I know about flocculant is that it helps me with my swimming pool, and I am very grateful that it's out there and that I can keep
Sure.
my pool nice and clear. But I know that is not what we're gonna. That is not necessarily what we're talking about today. So let's just let's unpack what flocculants are and kind of why we should use them and just kind of the basics. Let's start 101 for everybody, if you would.
Sure. Yeah. Just to make a note on that, it's just kind of a funny point is that we had a swimming pool in Georgia when we were growing up, and I will say that there were certainly some flock logs being tested.
Hey, that's what I'm talking about.
So
Like, it's
various
family owned
schools.
business. Of course,
Yeah,
you're gonna test in the backyard. Of course. That's
so
awesome. Can,
various
do you
schools.
have any? Do you have any small? Do you have anything like that that would help somebody out? No, I'm playing. I'm playing.
Unfortunately, we have
Don't
not
let
done
me don't let me squirrel off onto my pool problems, Kyla. I will cry on your shoulder. It is, actually our salt water is way better than our chlorine was. So I'm so happy to have a salt water pool now. It's been a lot easier, but I do like me some flocculant. But anyways, back to you.
any.
Go ahead and let's explain everybody. Let's do the 101 on
Yeah,
flocculant use and what it is.
right. So I feel like the words, flocculant, coagulant, polyacrylamide, polymer, a lot of these get used kind of interchangeably, and a lot of them are really similar. But basically, what a flocculant is, and what I'm going to be talking about today with the products that we have at APS are polymer flocculants that are made from polyacrylamide. So basically, what a polymer flocculant is it's a very long chain molecule. It's a water soluble polymer that's able to bind to particulate in the water, like sediment and metals, forms them into bigger, larger particles that can then settle out of the water column or be captured. So basically, flocculation is just the process of making little particles into big particles so we can get them out of the water.
I gotcha. And then I guess safety matters. I guess that's why all the testing. So like,
Yeah.
how does that lean into everything?
So the reason that we use polyacrylamide, our company is Applied Polymer Systems. It's not Applied Polyacrylamide Systems. So, we're open. We've worked with other types of flocculants as well, but the reason we primarily use polyacrylamides, which if you're familiar with flocculants for erosion control and stormwater treatment, you've probably heard of PAM or polyacrylamides. There's other polymers out there, so you've probably heard of, chitosan or maybe polydadmac or starches or cellulose. There's a lot of different polymers, but in our specific industry, we do so much work in the open environment. We're not in polyacrylamide is the same material they use in drinking water systems, wastewater, lots of different uses. But when we're doing work out in the environment on a construction site, we want to make sure we're using something that's going to be safe if it's discharged into a stream or some sort of receiving system. So anionic polyacrylamides have a very, very low toxicity, and so they're safe for fish. Again, they're drinking water grade materials. In some states, we've actually used them directly in streams or ponds and lakes. And so it's a really low toxicity, safe material. And that's why we specifically use polyacrylamides or anionic polyacrylamides specifically for stormwater treatment and erosion control.
So that's interesting as far as like all basically all polymers, all flocculants are not created equal. Is that kind of what we're saying? Like you've got to be careful on what you're doing or the application to which you're doing it with and the different types of available flocculants that are out there. Would
Yes.
that be, am I
Yes,
understanding you? Okay.
exactly. And so if you look at most of like the state, the cool thing about flocculants now is that, I mentioned that, we kind of started this over 25 years ago. And we came
Yeah, that's
down into an
amazing.
environment where nobody knew what this was.
Yeah,
Um,
of course.
it was like magic powder that,
Right. It still
yeah,
is to me. Just so you know, it still is
yeah,
magic powder. To you, not so much. But and I think I'd like to think I speak for a lot of people. I think it's still magic powder.
yeah. It does. I mean, it is. It does look like magic when you take a 500 NTU cup of water and turn it into near drinking water in 20 seconds. So it does. It is somewhat magical,
Oh
but
yeah, that is magic. That's magic. That would be
yeah.
the definition of magic, Kyla. uh, sorry, I interrupted you. Go ahead.
No,
Go
no,
ahead.
that's fine. Yeah. So, but the reason behind the safety of the anionic PAM, and now moving from no regulations 25 years ago to over half the states having some sort of manual or guidance or you know um, flocculants on the DOT list for the QPLs or the APLs or things like that just really exploded, especially in the
Mm,
last 15 years. But one thing, and basically how you know you're using a safe material is, first of all, you want to make sure you're using a different polymers have different charges. So, anionic is negatively charged, cationic is positively charged. Most states require that you use an anionic polymer in the environment for stormwater treatment and construction discharges. The reason for that is that fish have um, negative charges on their gills. And so, if you think about that concept, you've probably heard opposites attract and likes
okay.
repel. And
Yep.
so if we use a negatively charged polymer, it repels from those negatively charged gills and doesn't harm fish and other sensitive aquatic organisms. Now, there's other polymers out there that work really well, like cationic PAMs or polydadmac or things like chitosan. They work, but they have a positive charge. So, about the same amount it takes me to clear sediment from the water is the same amount that I'm going to bind to the gill surface of fish and cause toxicity. So those are kind of a no-no for environmental applications.
Yeah, yeah. We're not trying to take the fish out of the water, just the
Just
sediment.
exactly.
Um, so you mentioned some state stuff. Is there some resources out there that people, because that's a lot. I mean, of course, I'm not in the flocculant arena or world in depth as some of the folks that may be listening. So are there resources that people can go to, or where would you point them for them to be able to? Is that state by state, or do you all have some resources that they could utilize, or what should people
Yes.
do?
Yeah. So you can certainly look up your state. One of my primary roles at APS is I have focused a lot in, especially the last couple years, as different states add polymers to their manuals or their CGPs or things like that. Um, I kind of put on that research hat, and I have all the resources for the papers and the different peer reviewed literature and things like that. And so I can provide you and lead you to which state has particular guidance and where to find it. But at APS, we take training very seriously. Again, going back to that, we started when nobody knew what this material was, and making sure that people use it safely and effectively is it's good for us, but it's really good for everybody, in that we want to make sure that this technology is used in a way that it's safe for the environment and it's helping people take care of the problems that they have. And so we have a lot of information on our website. We also offer free training. We do webinars. We have a lot of different information in different capacities available for people that want to learn about what flocculants are, how to use them, and how to apply the flock logs and silt stop material.
I got you. I got you. So like she mentioned the website, and it's actually siltstop.com. So if you go to siltstop.com, that will take you to their website. And so in researching the pod, I was on your website earlier, and so here's the thing. So you think about flocculant, you think about demonstrations of that, and like you mentioned before, right? So you got the cup of water, it's got the turbidity in it, you put in the magic powder, and you spit it up, and then all of a sudden it's clear. Hey, awesome, right? And that's kind of where my brain stopped. So let's do this. We've got time. I didn't think about APS silk stop. It says that you can use it for dust control. Which, I mean, again, there may be people out there that go, there's Ty showing that he's not very bright again. But I didn't know. So I'm going to bring it up because I thought, hey, that's pretty cool that you can use a flocculant to knock down the dust for a period of time rather than, I mean, there's a lot of other ways that I see it done that kind of seem wasteful. But if you could just do it like that, do you want to speak on that? Maybe we just kind of go right across this board here that I'm looking at your website. It is just to open people's minds to, you know, what else can flocculants be, used for? So I'm looking at dust control, and I'll just go across the board. But you want to speak on a few of
Yeah.
these?
Yeah, so that's a really great point. I think a lot of times we get, the main applications that you hear about is, there's terrestrial applications for erosion control and soil stabilization. And then, the other main one would be treating our sediment control BMPs like rock checks, wattles, anywhere you have a silt fence or rolled erosion control products. If you use the granular silt stop with those, you basically turn those sediment control devices into water clarification devices. And then, of course, our flock logs, which we use for water treatment. So those are kind of our bread and butter that we almost always talk about, and that usually takes up the most time. But like you said, there's a lot of other things
Yeah.
that the flocculants can do that maybe we don't always put out there. But dust control is one of them. I like to say again, it's all about that agglomeration and pulling those particles together. So it's the same concept. If we have issues with dust, we can we can use a water truck to apply the granular silt stop or the liquid silt stop, and basically it'll hold those particles in place to prevent them from becoming airborne. And some of the benefits of that is you might know for dust control, typically you're using salts, magnesium or calcium chloride and things like that. They're really effective. They're hygroscopic. They pull all the moisture to the soil surface and it cuts that dust down. The problem is I'm in Michigan. I live up in Marquette, and in Michigan in the Midwest is we use a lot of salt for our highways in the winter,
Mm-hmm.
and so if you use too much salt, that also enters receiving systems and salts the streams. And so a polyacrylamide is a really great non-salt option for knocking dust down.
Awesome. Awesome. And then you also have on here, you've touched on, I think, three of the four, but you've got on here demucking, which I thought that was an interesting use of the of the product as well,
Yeah.
where you're trying to remove something and you don't want it dripping all over the place, and so you can kind of solidify it a little bit. Am I understanding that on a kind of a
Yep.
uh,
So
cursory
demucking.
level?
Yep, that's another one that we do on a regular basis, but just isn't as isn't one of the biggest applications. But this is a really it's a very interesting visual. I wish I had brought some sample cups. I could show you how that looks.
It's all right.
But
Most of this is a pod. I mean, it is going to be on YouTube too, but I always feel bad for those folks listening when we start getting into the visuals because they're like, now I got to go to YouTube.
oh, gotcha. Yeah,
So you're good. You're good. Go ahead.
yeah. So when we dewater, a basin and we have all that really high water content in our sediments, those can be really difficult and time consuming and expensive to remove. So if we use a flocculant, the flocculants, these ones are water soluble. There's actually other types of PAMs that they call them cross-link PAMs, and they'll absorb water, and that's what they put in like sweatbands and baby diapers. We're not using those ones
Oh,
specifically, but the ones that we are using do still absorb some water. And so when we mix it in with the sediment, we absorb some water, we bind with that sediment, and we can form that really, really thin, unmanageable muck and basically create a really thick material that you can just scoop up and haul away. Um, we've actually had people take demucked sediments, and I think they did this in Florida for a while. They would take those sediments that were treated now with polymer, and they would spread them out on the sides of roadways and use them for stabilization and help to establish vegetation. So
nice. All right, cool. So let's talk about the future then. So if I'm assuming 25 years of tinkering in the backyard pool, and then obviously in more sophisticated labs at this point. There's got to be things you're working on. I mean, is there anything out there that you can actually talk about that's not like, I don't want to spill the beans or anything, but just things that you're working on, future, or what you see future wise as far as the world that you're in, and what you guys are striving to do, or what you see, whatever
Sure.
you can, whatever you can speak of that's not going to get you in trouble, right? That's,
Yeah,
obviously everybody, a lot of times, you don't want to let out, oh yeah, we're working on this product, and like, oh, I should have said that, but
sure.
um,
Yeah. Yeah, no, so it's interesting in the United States because as I mentioned, there's some states that have really clear guidance that have been using
mhm,
this for a couple decades. And then there's other states that, have no guidance and maybe kind of sparse use. And so in the last 5 to 10 years, every couple years we see a new state adding this to their toolbox because they realize, again, with those physical BMPs, we have those really small particles. They just can't get the water quality with the physical BMPs. So really, there's a lot of room just across the US is that we are working to still train and educate and help people in these other areas of the US that maybe aren't familiar with flocculants, but really need flocculants to help them get their water quality where they want it. So we're still working kind of from the ground up in a lot of areas to train them how to use these materials, kind of the way that we've been talking about today. In terms of new products, I mean, there's lots of ways to use the flocculants. We didn't really get into how to use them effectively.
oh,
We site
well,
we
let's do
site
it. Go ahead. Yeah,
so
yeah,
we
please.
site test and match our different polymer formulations to each soil or water, usually aiming to get it somewhere around 20 NTUs with a site matched polymer. We make sure how long it takes. It takes about 30 seconds of mixing and reaction to fully form those flocks so they'll settle. And so there's a few things we want to do on site to make sure match it, get enough mixing and reaction, get enough of the material in the water. But once we have the basics of how to use the flocculants, you can use them in, especially the flock log, which is the gel log, the block product. You can
Okay.
put it in open channels. You can use existing stormwater conveyances. So you can put it in, an inlet or a pipe. We put them in pump and pipe systems. And so, we're always working at looking at new types of BMPs and ways to implement the flocculants. And so it's looking at new ways to use our existing products. We've also come out, again, this year has been kind of the year of training. It's just been kind of exploding the interest in flocculants. So we've been working with a lot of different people just on the basics this year. But what I was doing before 2023, we developed a new product that incorporated some plant polymers, some starches with the anionic polyacrylamides. We called it the bio blend log. So it's like half plant, half PAM. So we're always, looking at new
Awesome.
products and
That's
different
cool.
things. So we're doing new things that's available. But really what we're focusing on still is just kind of moving across and helping people in different areas that are looking to implement the flocculants.
So, I want to make sure I understood that right on the effectiveness side of things. So it seems like it's a little bit of art along with science. Like, do you have to really kind of test out the area, or before you actually use the certain product, or are you guys are you custom building a product based on what they're trying to do, or did I misunderstand how that's working on the testing before you just kind of jump in there? Like in other words, I just can't. I don't go to your website and just grab some stuff and just throw it into whatever, right? Like you need to kind of have a game plan on what you're trying to accomplish, and then test it
Yes.
before you go large scale. Is that
So ideally, what the test looks like is if someone, kind of we're starting from ground zero, someone calls and says, I've got a cleared area, I have some channels, they're leading to these basins, and the water quality, my turbidity is really, really high, I can't discharge. What do I do at this point? So if I want to introduce some flocculants. So the first step would be they send us a sample of soil or
oh,
water from that site.
gotcha? Okay,
We
okay,
do a free sample analysis, and basically, there's hundreds of different types of anionic PAMs just in the erosion control and stormwater space. So what we do is we take our common flock log and silt stop formulations, and we figure out which one's going to react with that soil and water from that site. If we don't do that test ahead of time, you could have no reaction, and the flocculant will be in the water, but it won't do anything. So doing that test ahead of time,
Gotcha.
it's maybe a couple days to us and a couple days back. We do the test in about 24 hours, and then we'll give you the results right after that. Again, it's a free analysis, and we'll know what's going to work on your site. So then once we know what formulation works, what we ask people is, what type of flow rate are we looking at? And then we'll tell you how much material you're using. What other types of BMPs do you have on site? Maybe here's some ways that you could use the silt stop or the flock log, or use them together. And so we'll walk through that. That's one thing Applied Polymer Systems does, that I think kind of sets us apart, is that from planning to implementation to maintenance to completion, we don't charge for anything but the products, but we're there every step of the way. If you're working with a state that has special requirements, we've done third-party toxicity testing on all of our products. We have all the documents, the certifications to back everything up. And so, we'll help with permits if they're needed. We'll help with dosing. We'll help with where to put
Oh, wow.
them. We do,
Yep.
we'll do a virtual, we don't do a ton of on-site work. We do occasionally, but we actually do, um, virtual meetings where we'll walk through a site. So we're there every step of the way to make sure that these are used effectively and that you get the results that you're looking for.
Awesome. And I would assume with that level of, I don't know if you want to call it customer service or that level, just that level of just being available, that you guys work with, like, I would assume are you working with manufacturers of other products and how they can integrate, and you guys have partnerships out there that you working through, so it's not just that person that needs that help with their their issue at the end user level, but are you guys working to try to upgrade the flocculant? Because I know there's products out there that are probably not using the best stuff, right? So you guys trying to forge through that too and work with some of these manufacturers to upgrade their products with what you all are doing and what you see
Yeah.
is from your testings?
Yeah. So right now, primarily what we do is, we're not working specifically with some of the other BMP manufacturers, but our products are not supposed to replace your traditional BMPs.
Gotcha.
We really promote it, is that you need to do the work and put the other BMPs in place, effectively. If you haven't done that, if you don't have the proper sediment controls on site, you're probably going to bury our flock logs, and it's not going to, work well for anybody. So we want to be using our materials in conjunction with all the other good BMPs that we have for sediment and erosion control. And what we do
Gotcha.
is we're an enhancement. So again, if you have those small colloidal clays that are going to blow through a silt fence, or a fiber roll or a wattle, and what we can do is we can use our silt stop or our flock logs so that that doesn't happen. We make those particles bigger, and now your other BMPs are functioning better and actually collecting those particles.
That makes sense. I can visualize that now in my mind. Thank you.
Sure. Mhm.
So what else do you have? Like, any final thoughts, like, on just stormwater erosion control in general? Anything you want to share with the listeners and what's going on, all the great things you're doing, or before we let you go? Oh, I will say this: like, we already gave out the website. We'll link that in the notes, and then I guess it's okay for people to find you on LinkedIn. Would that be
Oh
accurate?
yeah.
Yep.
Definitely.
And if you look for Kyla on LinkedIn, it's actually Kyla Iwinski Wood. Did I say that right? Iwinski. That's
Yep.
IWINSKI hyphen Wood. So Kyla Iwinski Wood on LinkedIn. You can look her up and message her with all your flocculent questions. But anyways, final thoughts. Anything else you'd like to share with everybody?
Yeah, thanks again for having me. I would just say that if anybody wants to learn more about flock log, silt stop, flocculants in general, we do like a PDH training series, and we have a lot of resources that we offer in house. So if you want to take a couple courses, learn more about the materials, we're available for that. So just reach out, and happy to set something up.
Awesome. Amazing. Thank you so much for taking some time today to visit with us here on the podcast, and I hope everybody got something out of that, and we'll look to enhance what they're already doing to make it a little bit better. We're all about the water quality, right? And broadening people's perspective on what's out there to tackle the problems that everyone's having in their stormwater world. So thank you again for coming on the pod.
Yeah, thank you.
Thank you for listening to this episode of the Stormwater World podcast. Do you have something you'd like to discuss? Do you have an opposing opinion regarding something you heard during this episode? Let's talk about it. Click on the link in the show notes to sign up for a future episode. I'd love to visit with you about what's happening and how you see things unfolding in your stormwater world.